Okay, there we go. Just had to make one quick edit. See how that goes. Oh, that's not bad. Okay, I can live with this. Let's see how that goes. Good. That's not bad. Okay. Okay, I'm back. Okay. So I have a question for people in the 97 class, really quick. Um, as I mentioned last week, since we missed on Wednesday there, uh, you guys said you wanted to do a makeup class, right? Okay, great. Is do you guys think Friday is okay? We could do it at the same time at 10 o'clock. I'll be more than happy to do a makeup class. I don't have a problem with that. I just want to be sure that the time works for everyone. Okay. Yeah, so that's again my promise to you because I don't like missing class at all. Trust me on that. Okay. So Friday, so our makeup class will be Friday at 10 a.m. Okay. Okay, so right here on Twitch. Okay, so nothing's gonna change in that regard. Gosh, darn it. All right. Someday I'm gonna fix that. Someday. All right. Okay, so Friday at 10 a.m. is going to be our time. Okay. I'll probably need to talk to LP to see how to make these adjustments. Man. Um. All right. Anyway. Uh. Okay. All right. So let's go ahead and get started here. All right. Okay. Let's get. Um. Am I? Am I? No. So, but a very valid question nonetheless. Um. All right. So we're gonna go ahead and get started here. So, okay. Let's get started today. Welcome back to Monday. Hopefully, have a nice weekend. All right, so today we're going to be going over the last section of chapter 3, and then we're going to get right into chapter 4 as well. So that's what we're going to be doing here in today. So we're going to be doing just 3 sections here today. We talked last time, and I know it's been a week, so but last time we did talk about decimals and getting stuff going in regards to decimal numbers. So that was very good. All right, so today we're going to be talking about decimal fractions. That's what we're going to be doing here today. So one of the things that I want to talk about here when it comes to decimal fractions in particular is to take a look at this table here. Now, if you're in the trades or anything like that, and you see this table can be shown on any wall or anything like that, and you'll see basically a chart of all the decimals with their fractional equivalents. Okay, so that's what you essentially see here on this table. All right, so you can see, for example, here 0.375 would be equivalent to 3/8. Now, why is this important? Well, it's because of the fact that if you're in a shop, then of course, if you're using, say, drill bits or things like that, then you're going to need to know the nearest equivalent to what you want to measure out at. Okay, for example. All right, so that's where this kind of fits into play here. Now, having said that, what we want to do here is, of course, be able to interpret other fractions to as its approximate, decimal equivalent as best as possible. So let's go ahead and take a look here, and let's do this out here. So, okay. So a lot of this you can do on the calculator, but I'll go ahead and show off one of these problems here. And where's the paint option there? Looking for the paint guy. There you are. Okay. Okay, so I'm going to go to the paint tool here really quick. So let's say we had 4 point, let's see here. Let's say 4.283. Okay. And I ask you, hey, can you find the closest fractional equivalent to 4.283? All right, that's what we want to do here. So what we're going to do here is we're going to separate the 4 and the 0.283. So essentially, this will be a mixed number of some type. So it's 4 plus 0.283. So we're going to have 4 and something. Okay, that's essentially what we're looking for here. All right. So if we have 4 point something, can anybody tell me what's the closest fractional equivalent that you see here on the table that's closest to 0.283? So according to the table here, what's the closest fractional equivalent? So take a look at the decimal 0.283. Take a look at the right-hand side. I'll make it a bit bigger here so it's easier to read. So apologies about that. Oops, that's not what I wanted. There we go. So which one of these fractions is closest to 0.283? Go ahead and type that out in the chat there. All right, wonderful. 9 over 32. Excellent. All right, so as you can see here, 0.283 is closest to the decimal of 0.28125. All right, it is between 0.28125 and 0.296875, but it is definitely closer to 0.28125. Okay. All right, very good. All right, nice work. So far, so good. Bueno. All right, so then this would be your answer here, 4 and 9/32. Bada bing, bada boom. All right, got it. Cool. Okay, let's take a look at another one here. Now, this one here is really easy, but this one here does have its importance nonetheless. So if we took 2/3, okay? Yes, that is correct. That is definitely correct there. All right, now, the next thing that we're going to talk about here is we're going to go ahead and take a look here at 2/3. Now, 2/3 by itself is not hard to figure out. You could go ahead and do that on a calculator of 2 divided by 3, and what it'll point out here, it'll do 0.6666666666666, and this keeps going on and on and on and on forever and ever and ever. Okay, so that's basically what that's basically what this does, is 0.6 repeating forever, essentially. So because of that fact, because you have 0.666 repeating forever, what we do is we want to represent it in a different light. Okay, we don't want to write sixes forever. Instead, we write it as 0.6, and we put a little line above it to represent that it's repeating an infinite number of times. Okay, so if we write there 0.6 repeating, this is how we write 0.6 repeating. You can write it as not this, but you can write decimals as multiple decimals repeating. So for example, 0.1828, and then maybe you want to write 1828 repeats, infinite amount of times. All right, whatever you want. All right, so you can do one number, you could do multiple numbers. If they keep repeating forever, it is what it is. All right, so it's not too hard. It's just like, okay, there it is. Perfect. All right. Okay. All right. Next, let's go ahead and take a look here at the next one. Thanks, Jack. I appreciate that, man. It was really fun watching LP go nuts. And see, I'm wearing the new kit to boot. You're always welcome here anytime, my friend. Anytime, Jack. Anytime, my dude. Come on by and just sit and chat, and you'll learn a little math. There you go. I'm on a little bit of a delay, so I do apologize. Uh, my computer's up to snuff. I'm just not sure how to stop it from buffering all the time. So, still trying to figure that out. Okay. Once I figured that out and be like, okay, that's cool. At least I can work with that. Okay. All right. All right, let's go ahead and do some problems here. Let's do them together. Yeah. All right. So let's do with number. Okay. Let's look at number 6. Okay, now number 6 will be one of those important problems that we'll certainly do here. A land developer purchased a piece of land containing 437.49 acres. He plans to divide it into a 45-acre recreational area and lots of 3/4 of an acre each. How many lots will he be able to form from this piece of land? So he's got a 45-acre like park, all right, for the kids, and then each lot for the house is 3/4 of an acre each. Okay, all right, and he has 437.49 acres here. Okay, so can anybody tell me here, what should I do first if I'm going to be able to solve this problem? Okay, I agree with that. 437.49 minus the 45. Totally agree with that, Jack. Very nice. All right. So, okay, so what do we get there if we subtract? I agree with everybody here. That's cool. So if we subtract 45, we get, you guys can use a calculator for that, so that's cool. All right, 392.49. Sounds like a plan. All right. Agreed with that. Completely agree. All right, now, what do we do after that? I agreed 392.49. That's how much acre space we got. We got to split up into lots of 3/4 of an acre each. All right, divide by, perfect, okay? Exactly. Both of you absolutely correct, okay? 392.49 divided by 3/4 or divide by 0.75. Both are perfectly acceptable there. All right, and what do we get here? $523, okay? Yep, okay. So, all right, that's correct. All right, so now 0 is correct in one regard, and let me go ahead and point this out here. 523.32 is correct. All right, so I'm not going to deny that whatsoever. But here's the thing about this part here, and don't forget about these kind of problems that you could run into. All right, so the issue with these kind of problems is that, yeah, you can't make 0.32, so it has to be 523. So it either has to, in certain contexts of a problem, you have to be aware that, yes, you may need to go ahead and round to a whole number answer because you can only form whole lots. Okay, you can't form 0.32 of a lot. So in this particular case here, oh, I want to put that there. 523.32 will be 523 lots. So there'll be some questions like this in the book which will reflect this point here, okay, where again you just need to be very careful about the context. We talked about at the beginning of the semester here. We said, okay, hey, when you're looking at word problems, you got to look at the context of the word problem. Well, this is where another context of the word problem is going to make a play here. So 523 will be your final answer for this problem. Very nice. Very nice. Easy peasy lemon squeezy. All right, any questions about that? Again, if you have no questions, go ahead and just type no in the chat, and then I'll move on. No? Okay. Nope. Okie dokie. All right. So again, it's not supposed to be too hard. I just wanted to point out the context part of the problem. That part is important. All right. All right. Let's take a look at one more here. All right, so we'll do number 16 here, a carpentry problem. All right, for interior trim jobs, some carpenters prefer to use MDF, medium density fiberboard, while others prefers to use finger jointed trim. If MDF costs $1.12 per linear foot and a finger jointed trim costs $1.68 per linear foot, what would be the total cost difference between the two materials for a job involving 38.25 feet of trim? Okay. All right, so let's go ahead and do this one out here. All right. What's another way to write 38.25? What's the decimal way of writing 38.25 real quick? All right. Simple enough, right? 38.25. Sounds like a plan. Now we're going to go ahead and multiply by each of the respective amounts. Okay, so let's go ahead and write that out. It's not hard, obviously. It's just go ahead and shrink this down a bit. This is my jank way of doing things. All right. All right, so we'll multiply that by $1.12. And then we'll do the same thing here for the other one. Okay. What do we get for the first one there? Okay, we get 4284. Spot on. And how about the second one? 6426. All right. Spot on. All right. Okay. Now remember what it does ask us here specifically. It tells us what's the cost difference between the two materials, right? So what's the difference of cost here between both of these types of materials once we subtract them out? $21.42. All right, easy time, easy life. All right, so you can see that the problems there aren't like super hard. It's just like, oh, okay, they're there. It doesn't take a rocket scientist to do most of these problems. But again, obviously, if you're in a shop, then you're going to have a calculator, a simple one with you that you can kind of bip bop boop on. But again, we're just going through the kind of the mental process about how to do this kind of critical thinking, about how to get to the final result for these problems here. So it's not too hard. It's just again, just kind of going through the motions there into putting it all together. All right. Okay. Any questions about that? Nope. Solid. All right. All right. All right. This isn't me. This is one of these days I'm going to get that fixed. All right. I'm going to get this fixed eventually. Someday. Someday I'm going to get these buffering things fixed. All right. All right. Next. NEXT, next. All right. Next, we're going to go into chapter 4. All right, let's do it. Chapter 44. All right. Man, you hate me today. Man. Okay. Okay. Let's do this here. Okay. So chapter 4 here is going to be on ratio and proportions. Okay, so the way we do ratio and proportions isn't too hard. Let's just talk about the keys here behind ratio and proportions. All right, so we'll discuss that, and then we'll see some examples here. So the key here is actually to label your units. Okay, label your units is going to be very important in ratio and proportions. All right, so again, if we talk about ratios here, ratios are things that you can certainly find in cooking. Say, for example, here, 1 part sugar to 2 parts flour, something to that effect. Okay, so you would have, say, for example, here, ratios you would see 1 to 2, or you would see, say, 1:2. Okay, that would also represent 1 to 2. All right, if you have like a lawnmower, then maybe you're mixing oil and gas, and it's like 1 part oil to 10 parts gas or something to that effect. Usually that's written in the owner's manual. So something like that would be a good example. Now, so that's basically how ratios work. It's really not too hard, but again, we want to go ahead and label the units here appropriately, depending on what we have. So let's take a good look here at an example, though. Where is it? There it is. Okay. This is going to find on page 203. There we go. Okay. So here are some ratios that they give us. For example, they tell us what the gear ratio is. They tell us, for example, here how many teeth are on gear A compared to gear B. Now this is a poor man's representation because gear A is not always necessarily bigger than gear B, determining on the number of teeth. It could look like this. It could look like anything depending on what the gear ratio is going to be. So let's take a good look here at some of our ratios here, I suppose. So for example here, here's one, a 1 to 3 gear ratio. So gear ratio says A over B. All right, that's essentially what it says. And that's pretty fair. Now, the thing is though, is that we want to make sure that gear A is on the top and the number of teeth on gear B is on the bottom. All right, so that's where kind of like the labeling of units is going to come into play. So if we put it like this, we say, all right, we're like, okay, hey, let's go ahead and take a look here. So we should have, again, gear A teeth. Okay, so we should have gear A teeth on the top and gear B teeth on the bottom. Now we're given a ratio of 1 to 3. Okay, that's what we're given here. So if I have 15 gear A teeth on the top, I'll put GA on the top for gear A. And I have X amount of gear B teeth on the bottom. I'll put GB for gear teeth. Then that should equal 1 gear A teeth and 3 gear B teeth. Now the way you figure this out here is, of course, to go ahead and one of the keys here, key number 2, is to, again, cross multiply to solve for the missing amount. Okay, so when we talk about, say, algebra and stuff, this is kind of like the beginning throes of a little bit of algebra here, which isn't too bad. So, but we will cross multiply here to easily solve. So cross multiply this and cross multiply this. So again, we have, as you see here, we have 1 times x, which is just x, and that equals 15 times 3. And so here we get x is equal to 45. So 45 gear B teeth is what we get here for this particular problem. All right, that isn't too bad. Any questions about that one? I'm not trying to make it hard, I promise. Okay. No, they say. All right, fine by me. Let's go ahead and take a look at another one here. Maybe sometimes you need to go backwards a little bit. So let's look at letter I, 27 in gear A, 18 in gear B, and we want to find a ratio here. So we go 27 in gear A, so let's write that out. I'm going to write this out here. So we have 27 over 18. Now, if we want to write the proper amount, the proper ratio here for gear A teeth to gear B teeth, let's go ahead and reduce this down. What can we reduce this down by the way? What sounds like a plan?